Good day, everyone. Good day, Miss Willeen. We are the last reporter, and we are going to discuss the globalization and technological advancements. And before we discuss furthermore about globalization and technological advancements, I am going to present to you our learning objectives. So at the end of the discussion, you will be able to define what is globalization and technological advancements. And second is to identify the effects of globalization and technological advancements to the economy and to the people. And the last one is you will be able to describe how globalization and technological advancements change the lives of the people. So that's our learning objectives in today's discussion.
Good day everyone, my name is Evelyn B. Mayormita, taking a Bachelor of Secondary Education, major in Social Studies, and for today, I will be discussing about the advent of mass production. So mass production is a manufacturing of the same standardized product lines for a prolonged period of time. It uses automation or assembly lines to facilitate the high volume production of similar products. Mass production, application of the principles of specialization, division of labor, and standardization of parts to the manufacture of goods. Such manufacturing processes in high rates of output at low unit cost, with lower cost expected as volume rises. Mass production methods are based on two general principles. The first one is the division and specialization of human labor, and the second is the use of tools, machinery, and other equipment usually automated in the production of standard, interchangeable parts and products. The use of modern methods of mass production has brought such improvements in the cost, quality, quantity, and variety of goods available that the largest global population in history is now sustained at the highest general standard of living. Next is the mass customization versus mass production. Mass customization involves providing end users with that suits their needs at a lower cost. Thus, products that meaningfully meet customers' needs are customized on a large scale. The conventional firms that deal with mass customization call for flexibility, responsiveness, and the configuration of units, processes, people, and environments to provide uniquely customized products that meet user requirements at a relatively low cost. Mass customization focuses on markets with fragmented customer segments and with customers' preferences being harder to hypnotize and prone to changes. More intimate knowledge about end users and higher profits creates a feedback loop system which can help companies provide even better and different products. In contrast, mass production is the forerunner of mass customization. Mass production companies replicate a hierarchical and bureaucratic system where workers perform repetitive roles that are narrowly defined, resulting in standardized, low-cost products. Consumers generally accept standard products under a mass production system. On a mass basis, companies manufacturing goods benefit from economies of scale since it facilitates market expansion and price reduction. The low product pricing encourages demand clusters and homogeneous products. It acts as a feedback loop that reinforces standardized products to the manufacturing firms, given the interplay between consumers and producers. However, the two concepts are viewed to be a continuum of continuous improvement. A company may also practice mass customization and mass production, albeit in two different factories meant for different market segments. So the advantages of mass production. So high precision rate. Mass production can result in a high precision rate if production is strictly monitored and validated using present parameters. Low production cost. Number 2 is the low production cost. It also associated with low production cost because The mechanization eliminates redundant job roles, thus requiring fewer workers. The third one is higher efficiency levels. Additionally, mass production can lead to higher efficiency levels since automation assembles mass-produced items faster. It also gives firms a competitive edge and higher profitability because the rapid assembly helps in the faster distribution and marketing of products. Then we have the disadvantages of mass production. First, mass production requires automated assembly lines, which is capital intensive and requires large sums of investments to set up and maintain. Only companies with large capital outlay can implement mass production in their manufacturing process. Second, mass production systems require upgrading and new improvements to keep up with the latest innovations in the market. A typical scenario can be seen in a pharmaceutical firm that manufactures popular drug products in a comprehensive assembly line. If a different production process is required to regulatory changes, the company will be required to incur significant investment in time and money to adopt a new assembly line. And lastly, mass production is associated with low employee morale and increased levels of employee turnover due to the repetitive nature of the production process. The principle of the division of labor and the resulting specialization of skills can be found in many human activities, and there are records of its application to manufacturing in ancient Greece. The first unmistakable examples of manufacturing operations carefully designed to reduce production costs by specialized labor and the use of machines appeared in the 18th century in England. They were signaled by 5 important inventions in the textile industry. The first one is John Kay's flying shuttle in 1733, which permitted the weaving of large beads of cloth and significantly increased weaving speed. The second is Edmond Cartwright's power loom in 1785, which increased weaving speed still further. The third is James Hargreaves' spinning jenny in 1764. The fourth is Richard Arkwright's water frame in 1769. And the fifth one is Samuel Crompton's spinning mule in 1779. The last 3 inventions improved the speed and quality of thread spinning operations. A sixth invention, the steam engine perfected by James Watt, was the key to further rapid development after making major improvements in steam engine design in 1765. Watt continued his development and refinement of the engine until in 1785 he successfully used one of a cotton mill. One whose human, animal, and water power could be replaced with a reliable, low-cost source of motive energy, and the Industrial Revolution was clearly established, and the subsequent centuries would witness invention and innovation the like of which could never have been imagined. In 1776, Adam Smith, in his Wealth of Nations, observed the benefits of specialization of labor in the manufacture of pins. Although earlier observers had noted this phenomenon, Smith's writings commanded widespread attention and helped foster an awareness of industrial production and broaden its appeal. So the next major advance was made in 1797 when Eli Whitney, inventor of the cotton gin, proposed the manufacture of flintlocks with completely interchangeable parts in contrast to the elder method under which each gun was the individual product of a highly skilled gunsmith and each was hand fitted. During the same period, similar ideas were being tried out in Europe. In England, Marc Brunel, a French-born inventor and engineer, established a production line to manufacture blocks or pulleys for sailing ships using the principles of division of labor and standardized products or parts. Brunel's machine tools were designed and built by Henry Maudslay, who has been called the father of the machine tool industry. Maudslay recognized the importance of precision tools that could produce identical parts. He and his student Joseph Woolsworth also manufactured interchangeable, standardized metal bolts and nuts. By the middle of the 19th century, the general concepts of division of labor of machine-assisted manufacture and assembly of standardized parts were well established. Large factories were in operation on both sides of the Atlantic, and some industries such as textiles and steels were using processes, machineries, and equipment that would be recognizable even in the early 21st century. The growth of manufacturing was accelerated by the rapid expansion of rail, barge, ship, and road transportation. The new transport companies not only enabled factories to obtain raw materials and to ship finished products over increasingly large distance, but they also created a substantial demand for the output of the new industries. At this point in the Industrial Revolution, the methods and procedures used to organize human labor to plan and control the flow of work and to handle the myriad details on the shop floor were largely informal and were based on historical patterns and precedents. One man changed all of that. In 1881, the Midvale Steel Company in the United States, Frederick W. Taylor, began studies of the organization of manufacturing operations that subsequently formed the foundation of modern production planning. After carefully studying the smallest parts of simple tasks, such as the shoveling of dry materials, Taylor was able to design methods and tools that permitted workers to produce significantly more with less physical effort. Later, by making detailed stopwatch measurements of the time required to perform each step of manufacture, Taylor brought a quantitative approach to the organization of the production functions. At the same time, Frank B. Gilbert and his wife Lillian Gilbert, U.S. industrial engineers, began their pioneering studies of the movements by which people carries out a task. Using the new technology of motion pictures, the Gilberts analyzed the design of motion patterns and work areas with a view to achieving maximum economy of effort. The time and motion studies of Taylor and Gilbert provide important tools for the design of contemporary manufacturing system. In 1916, Henry Fayol, who for many years had managed to a large coal mining company in France, began publishing his ideas about the organization and supervision of work, and by 1925 he had initiated several principles and functions of management. His idea of unity of command, which stated that the employees should receive orders from only one supervisor, helped clarify the organizational structure of many manufacturing operations.
Once again, good morning everyone. I am Eva Almagrace Melan, and in my part, I will be discussing to you guys about the machination of progress. Machination of progress refers to the discovery of new and improved methods of producing goods. Changes in machination lead to an increase in productivity of labor, capital, and other factors of production. Machination of progress involves the invention of technologies and their release as open source via research and development, the continual improvement of technologies, and the diffusions of the technologies throughout the industry or society. So I have here three phases of technological progress. These are the invention, innovation, and diffusion. First, we have invention. Invention is the process of creating new technology or developing a product or a technological process by applying knowledge that was already in use, but in new ways. Invention always begins as basic working models in which essential features are developed to gauge their chances of working. After the essential features are developed, an improvement that includes addition, subtraction, or modification is then carried out to the basic working models until every improvement that could be added to the essential features. Next, we have innovation. This is the second stage of technological change, and it refers to applying the invention discoveries to produce a useful product or a process. It is an idea, behavior, or product that is new to the adopters. So there are two types of innovation: product innovation and process innovation. Product innovation refers to the development of improved products, while process innovation refers to using an improved method of production to create superior products. Next is the diffusion. This is the last stage of technological change, and it involves the spread of improved technology throughout the industry so that the pioneer company can remain competitive. It is also the process where new ideas or products are accepted by the market. So I will give you guys an example of technological progress. An example of technological progress is how mobile phones have changed and evolved throughout the years, from the telephone to mobile phones and to smartphones. So what are the impact of technological change? As we all know, we are all likely experience the impact of technology, and we are all really enjoying it. So first thing is, it creates new product and processes. When telephones were first invented, the object was to be able to verbally communicate with someone. Due to the technological changes, we have multiple ways to communicate using our phones, such as text, email, or talk. Second, it increases efficiency and lower cost. Technology make it possible to perform every task faster and with less energy on our part. For instance, some people have a vacuum cleaning robot. Instead of spending 30 minutes vacuuming, they just push a button go and do something else. The last one, it helps economies evolve. People are able to increase the ways in which they create wealth. When one technological change occurs, it changes how we live. Just like, for example, we can make money through technology, like vlogging, online business, and many more. And it really have a good contribution to our economy. So why does machination of progress is important? Machination of progress is the most important factor that determines the rate of economic growth. It plays an important role in the capital formation. It is the change which can bring about continued increase in output per head of the population. Thus, it is the prime mover of the economic growth. The increasing use of machinery and other capital goods in production, along with technological progress made possible by increasing knowledge, have been the foundation for rising living standards in the long run. The progress of the discovery of the new and improved methods of producing goods that resulted of the increasing the productivity of labor, capital, and other resources. The productivity of combined inputs of all factors is called total factor productivity. As a result, it becomes possible to produce more output with same resources or the same amount of product with less resource. So why spreading machination matters? Machination of progress is a key driver of improvements in incomes and standards of living. Therefore, the way machination spread across countries is essential to how global growth is generated and shared across countries. Indeed, during 1995 to 2014, the United States, Japan, Germany, France, and the United Kingdom produced 3/4 of all patented innovations globally. Other large countries, notably China and Korea, have started to make significant contributions to the global stock of knowledge in recent years, joining the top 5 leader in a number of sectors. While this suggests that in the future, they too will be important sources of new technology during the period under study. Next is the globalization and its impact on technological development. Globalization is the main feature and an inevitable process of the time we live in. It allows for the global movement of people, ideas, informations, technologies, and capital. It erases the outdated borders and helps establish more intense and dynamic connections between global and local events. On the other hand, today's world of turbulent changes shows beyond doubt that modern development depends on innovations and technological development. Technology makes globalization easier and possible, while globalization adds value and increases the availability of technology. Thus, globalization accelerates the development of new technologies and increases the value of new technology by increasing its potential market. Technology also facilitates globalization, while globalization makes technology more valuable. So why does economy need permanent technological progress? It is widely accepted that technology is the key driver of economic growth of countries, regions, and cities. Technological progress allows for the more efficient production of more and better goods and services, which is what prosperity depends on. Technological advancement and economic growth are truly related to each other. The level of technology is also an important determinant of economic growth. The rapid rate of growth can be achieved through high level of technology. Innovations or technological progress is the only determinant of economic development. Thus, it is the technological progress which keeps the economy moving. Inventions and innovations have been largely responsible for rapid economic growth in developed countries. The evolution in technology has been successful in creating innovations as well as the impactful changes that made things easier for people worldwide. In recent years, people in business have realized the importance of technological advancement because it innovates new tools that efficiently deal with all the complexity. Technology has gathered a lot of fame recently, and it can be an excellent advantage to the business sector as well. The technological advancement has been one of the trends that the business sectors are focusing on. It made things effortless and convenient for businesses all around. One of the reasons why the business sector needs technological advancement is that it increases the demand for goods and services from people worldwide. It also increases the scope of businesses, a better customer service, and a higher revenues. The concept of digitalization didn't come as the replacement of the traditional method. Still, it came as an essential element that automates few things in the business operations and eliminates few things, and also it increases the business productivity.
Good day to each and everyone. To continue the discussion, my part which is globalizing trade. When we say globalizing is the word used to describe the growing interdependence of the world economies. According to the instructor Sean Grimsley, a Master of Public Administration in Political Science, global trade definition is the exchange of products between international borders. It is the lifeblood of the world economy since it allows different countries to expand their markets and help in the availability of products that may not be available domestically. Global trade, also known as the international trade, works through a flow of huge complex supply chains between the countries. The exchange products in international trade can either be export or import. When we say import, it is referred to the products that are brought to the local nation. On the other hand, exports refer to the product sold to a foreign nation. Global trade occurs mainly because one nation enjoys comparative advantage in manufacturing particular products. How did globalization affect trade? Globalization has resulted in greater interconnectedness among markets around the world and increased communication and awareness of business opportunities in the far corners of the globe. More investors can access new investment opportunities and study new markets at a greater distance than before. An example of a global trade country, which is that China imports crude petroleum from Russia and Saudi Arabia. There are numerous benefits of international trade. We have the first one, economic growth. International trading is a primary to reducing worldwide poverty because it helps open vast job opportunities. Countries that participate in global trading tend to grow faster and improve productivity and innovation. This is because international trade leads to the development of new industries in order to meet demands in different countries. The second one, which is reducing international conflicts. Global trade leads to the development and establishment of peaceful relations between countries. It also creates understanding, cooperation, and cordial relationships among different countries. When people from different countries come in contact with each other, the commercial mixing between them encourages the exchange of cultures and ideas. And the last, which is specialization. Global trading leads to specialization and promotes the producing of different products from various countries. This means that goods can be produced at a relatively low rate due to the division of labor. Before I'm going to end my discussion, according to the quote of James Forrestal, for the only way in which a durable peace can be created is by worldwide restoration of economic activity and international trade.
Good day, ma'am. Good day, classmate. I am Andres Trisqueo Ibanez, and I am the last reporter, and we are going to talk about the shift from industrial age to computer revolution. So first, we are going to talk about what is industrial revolution. A period in which human work, play, and interaction patterns are fundamentally affected by systems geared to processing and distributing energy. Energy that is harnessed to provide large-scale travel. The Industrial Revolution was the transition from creating goods by hands to using machines. It's a start and are widely debated by scholars, but the period generally spanned from about 1760 to 1840. According to some, this turning point in history is responsible for increase in population, an increase in the standard of living, and the emergence of capitalist economy. And now, we will talk about how industrial revolutions started. The first industrial revolution began in Great Britain in the mid to late 1700s, when innovation led to goods being produced in a large quantities due to machine manufacturing. This spread around the globe, and the second industrial revolution began in US in the late 1800s that saw further advancements in technology that led to greater efficiency. The Industrial Revolution shifted from an agrarian economy to a manufacturing economy where products were no longer made solely by hands but by machines. This leads to increased production and efficiency, low prices, more goods, improved wages, and migration from rural areas to urban areas. And now, the change of industrial age to economy. The Industrial Revolution transformed economies that has been based on agriculture and handicrafts into economies based on large-scale industry, mechanized, mechanized manufacturing, and the factory system. New machines, new power sources, and new ways of organizing work made existing industry more productive and efficient. So now we are going to talk about the inventions. The inventions in the Industrial Revolution. So the first invention in Industrial Revolution was the spinning jenny. The spinning jenny is the spinning of cotton into threads for a weaving into cloth had traditionally taken place into the homes of textiles workers, known as cottage industries. But the 18th century saw the emergence of Industrial Revolution, the great age of steam, canals, and factories that changed the face of British economy forever. James Hargreaves' spinning jenny, the patent for which it shows her, would revolutionize the process of cotton spinning. The machine used 8 spindles into which the thread was spun, so by turning a single wheel, the operator could now spin 8 threads at once. This increased the 80 with improvements in technology. Second invention was the Newcomen steam engine. The atmospheric engine was invented by Thomas Newcomen in 1712. It was the first machine to be powered by steam and was largely used to pump water out of mines. Hundreds of these engines were made and used all over Britain and Europe in 1700s. They became known simply as the Newcomen engine and helped pave the way to the Industrial Revolution. And the third was the Watt steam engine. James Watt's steam engine had an enormous impact in 18th century industrial society. It was more efficient and more cost-effective than earlier models. What's more, Watt's steam engine opened up an entirely new field of application. It enabled the steam engine to be used to operate rotary machine in factories such as cotton mills. Unsurprisingly, demand for Watt's steam engine was high, and it was quickly adopted across multiple industries. And the last one was the locomotive. It was famous incarnation in steam-driven locomotive. The union of steam and iron rails produced the railways, a new form of transport which boomed in later 19th century, affecting industries and social life. The steam engine was central for the Industrial Revolution. Only through providing a convenient source of energy could major forms of transportation grow and prosper. The steamships and the steam locomotives allowed for the quicker transportation of raw materials that could be used to produce finished goods. So that's are the famous inventions in the Industrial Revolution. Industrial Revolution was a time of great imagination and progress. The inventions that allowed new products to be manufactured create a demand that caused a vicious cycle that propelled some people to prosperity, while at the same time held people down in poverty. It was also never the intent of the inventors, scientists, and other brilliant people to cause such chasm between working class and industrial machine, but it was none other less created. And now we are going to talk about the shift to computer revolution. So the shift from the mechanical and analog electronic technology to digital electronics as means of storing, transferring, and utilizing information is credited as the starting point of what we refer to as the digital revolution. It began in the second half of 20th century with the adaptation and proliferation of digital computers and digital storage for information, which in turn led to development of more advanced computer systems able to digitally replicate and automate the previously manually performed mathematical calculations. And now we are going to talk about the positive and negative effects of computer revolution. So the positive effects of computer revolution was greater interconnections, easier communication, and exposure of information that in the past could have more easily been suppressed by totalitarian regimes. So regarding the economic impact of digital revolution, there has been a wide range of impacts. For example, without the advent of the internet, globalization would not be feasible venture in today's world. The revolution altered the way individuals and companies interact with each other. Small and medium enterprises today have access to large markets of the world. The adaptation of digital technologies has resulted in a boost in economic productivity and its allied activities. With the increase of technical advances, the digital revolution has created a demand for new job skills. So that is the positive effect of the the computer revolution. As we all know, we talk about the positive effects of computer revolution. So now we're going to talk about the negative effects of computer revolution. So the first negative effect of the computer revolution was information overload. The rise in internet predators, forms of social isolations, media saturation, and infringement in personal privacy. There have been some cases where excessive use of digital devices as well as computers for personal use has been linked to a company's productivity, or at least such a perception seems to exist. Personal computing and other non-working related digital activities in the workplace thus help lead to stronger forms of privacy invasion, such as keystroke recording and information filtering application, or spyware and content control software. So that's the negative effect of the computer revolution. But the computer revolution has been considerable benefits to society at large, but it has also brought its fair share of concerns in the process. Powers of communication and information sharing has been widely expanded, and with it, new technologies that can exploit the information concerns have also cropped up. It has ushered a new scenario where mass surveillance can become the norm, bringing in its wake new concerns about civil and human rights. So that's my report. So that's the end of my report about the industrial age shift to computer revolution. So thank you everyone. Thank you for listening to our report. God bless you all.